Stanford University.
So welcome to Stanford CS193P. This is Developing Applications for iOS, winter of 2017. So this is the only lecture, I believe, in this quarter where I'm not going to do a demo. Okay? So this is all slides. And that's because I'm pretty much going to try and get you up to speed fully on Swift. Now, everything that I'm going to talk about today is covered either in your reading assignment 1, which was due today, so hopefully you're done with that, or it's in reading assignment 2, which is going out today and is due next Wednesday. And so why am I even covering this? Because I know that reading through that reading assignment can be a big slog through a lot of information, and I want you to understand the things in there that are really important, okay? And so as I go through the slides today, if you see something and I explain it and you're like, oh my gosh, I didn't get that, just make a note about whatever the topic is that I'm talking about, and then you can go back and read about it again in your reading assignment to try and understand it. If you still don't understand it, you can, of course, ask on the class forums. All right? So you can think of this as kind of the highlights of the first 2 reading assignments. Now, some of these are also highlights of the first 2 lectures I did in the demos. So there's a little bit of that in there, too. But this is really kind of the important stuff in Swift that I can teach you at this point. There's more important stuff in Swift to come. Okay, but I'll be teaching it kind of as we go in the next 2 weeks. All right? Okay, so a lot of Swift topics. Let's start with the first one, probably everybody's favorite topic when they first learn Swift, which is optional. And optional is interesting in Swift because not a lot of other languages have optional, so I'm sure, in fact, I've heard that some of you are like, I'm not sure I really understand that optional thing. And that's probably okay, but you know, by the end of next week, you should feel very confident with optionals because you're going to see that they're absolutely everywhere in iOS. Now, I mentioned this in the lecture, but I wanted to show it to you from a code point of view, which is that optional is nothing more than an enum. It is, in fact, just an enum. This is the enum that is an optional. It's a generic type, kind of like array. You know how array, when you say the type, you say the type of the thing you're putting in the array. Okay, you should all be familiar to that. With that from Java, for example. Same thing in Swift. So in optional, same way. You put this type. And the type that's associated there, or not that's associated, but the type, the generic type that we're talking about, that T in an optional, is just the type that's going to be the associated value. Okay? So you look at this enum optional. It only has 2 cases. I told you, none, which is not set, and some, which is set. And when it's in the sum case, look, parentheses T, you know what that is from the calculator demo. That's an associated value. Okay, just like when we had operation in calculator, it has associated values, like unary operation had an associated value of a function, and constant had an associated value of the constant's value. Same thing here, optional. In the sum case, the set case, it just has an associated value, and it's whatever type the optional is. So if this is an optional string, that would be a string. Okay? Now, what makes optional, like, you're like, oh, I don't really get optional, what is it? Is because of all those question marks and exclamation points. Okay, but all those question marks and exclamation points is just sugar, syntactic sugar, to make your code look a little simpler and straightforward because it's so common to use them. So I'm going to map this enum to that sugar. Okay, so let's take a look. Here's the first one. If I say let x be an optional string that equals nil, that's exactly the same as saying let x equal optional dot none, okay, and angle bracket string as the kind of optional I want. Just like if I said array, I'd say angle bracket string. That would mean I want an array of strings. Well, here I want optional angle bracket string. That means I want an optional string. And I'm putting it in the not, I'm picking the none case. And same way, if I say let x equal an optional string that equals hello, I'm just saying x equals optional angle bracket string dot sum with associated value hello. Everyone got that? Okay, so that's all that's happening there with the question mark thing. And then here is the unwrap. So when we do that exclamation point, all we're doing is doing the switch, you know, that to get things out of an optional. The associated values, we switch. So we're switching on the optional. And we're saying if it's in the sum case, then we're going to grab that associated value, just like we did in the calculator when we said let function or let value to grab the associated value. We're saying let value here. And it's grabbing that value that's associated with it. And if it's in case none, where it's not set, it raises an exception and crashes your program. Okay? We haven't talked about how to do that. It's quite easy. But that's what happens here. So that's all exclamation point is. It's basically a switch. All right? And then, finally, if we do the if-let, okay, if-let is also just a switch. But in the none case of an if-let, we don't raise an exception. We just break out of the switch, do nothing. Okay? That help you a little bit understand what optional is? Optional is a type. It's an enum. It's just like any other type. It just kind of has this interesting behavior, and it's got all the question marks and exclamation points to make all the code look a little simpler. Now, there's even other stuff about optionals that are interesting. Optionals can be chained. Okay? And what does this mean? Well, this is best shown by example. So let's say I have a optional UI label, like my display in the calculator, and it's got the text. That's also an optional, right? Optional string, we all know that. And let's say I want to get the hash value, which is just a var on string, which hashes the string, gives you some integer for it. I want to get that hash value of what's in the display. So I would probably do some code that looks like this. This is probably similar code to what we have in our calculator, where I've got my display, right? That's my IB outlet probably, that display UI label question mark. And I'm going to go do if-let here because I don't want to crash, so I don't want to do exclamation points, okay? So I'm going to do if-let. So I'm going to say if-let some temporary value equals to the display. Now temp1 is the UI label. And then I say if-let temp2 equal temp1.text. Okay, I'm sending text to the UI label. And now I'm getting back a string. Not an optional string, but a string because I did if-let. And then I can finally say, then let x equal temp2, which is the string, hash value. Okay, this is a lot of code to have to type to just get that dang hash value out of that UI label's text. So with optional chaining, this same code looks like this, the first line of those two lines. If let x equal display question mark dot text question mark dot hash value, then do something with x. Okay? And in that case, of course, x will be a non-optional because I'm doing if-let on it. If I take the if off and just do let x equal all that, then x will be an optional int. Now, how is this working? What's happening is every time you have one of those question marks after an optional, it's saying, if this is in the set case, then grab it and keep on going, right? Send the next thing. If it's in the nil case, then just return nil for this whole expression. This entire line, boom, it's just going to return nil. And if I'm if-letting it, then obviously the code won't get executed. All right? And you can do this, as many of these as you want in a row. And we do this all the time. Okay? This optional chaining, it's going to be all over your code. And it makes perfect sense because, again, we're using this question mark and exclamation point. Here we're happening to use the question mark when we're accessing it versus when we're declaring it. Okay? So that's what it means to use a question mark when you're accessing it. It means go get it, and if it's not set, then just return nil from this whole expression. It'll just bail out of the whole thing. We'll never even execute hash value because we'll never get down to that end of it if any of these things are nil. Okay? Got that? Okay, another cool optional things we can do is optional defaulting. Okay? So what if we wanted to put a string in our UI label, like in our display, but we know that if that string is nil, we don't want to put nil in there because what will happen to our label if we put nil in as the text? It'll collapse down, right? Probably most of you saw that. You have to put something in there, at least space. So let's say I want to do that. I want to put space in there if it's nil. So again, this is the code that it would look like here. If I had to have my string, I would say, if the string is not nil, then put it in the display. Otherwise, if it is nil, put space in there. Okay? So this looks a lot cleaner with optional defaulting, which looks like this. Display.text equals s, question mark, space. And that means if s is nil, use this other thing. So it's like the default in case s is nil. Okay? You will use this all the time as well. Everybody got that? Just optional defaulting. All right? So I bring those out of the optional world just to highlight them. There's a lot in the reading that you're doing about optional, but these are kind of the highlights. There's a couple more things actually I'll show you later, but that's basically it for optionals. All right, tuples. Okay, so I had you skip tuples in reading assignment 1, but you'll be reading about it in assignment 2. What is a tuple? Tuple, super simple. It's just a grouping of values. And you can use it anywhere you're using a type. What does a tuple look like? It looks like this. This var here, this constant actually x, I'm setting its type to be a tuple with a string, an int, and a w. That's its type. Okay? A tuple can have any number of things in there, but realistically we probably only have 3 or 4, sometimes only 2, but it can have any number. And so I can set x equal to, parentheses, those 3, any value of those 3 types. So here I've set it to hello, 5, and 0.85. Now I can get the values out into individual variables by saying let, parentheses, 3 different variable names, equal x. And now it will pull out the 3 different values into the 3 separate variables, word, number, and value. Okay? So it's kind of mirror image there. You can kind of go either direction, putting things in or out. Now, we actually, believe it or not, don't do it that way most of the time, because it's also possible to name the elements of a tuple. So here I've defined x, same thing, string int double, but look, I've named each of them. I called the string part w, I called the int part I called the double part v for some reason. Okay? Now I still set it equal in exactly the same way, no difference there, but now I don't need to pull it out into separate variables. I can just say x.w and get the w, the first component of it. You see that? This is how we do tuples with names. I strongly recommend you almost always use names with tuples. It's just a little easier to read, clearer to say what your intent is as a programmer, because those names can have good variable, the names of the parts of the tuple can have good variable names. And you're going to see in your assignment number 2, program assignment number 2, I'm going to have you write a function that returns a tuple. Okay? And it's going to specify the names of the parts. Now, even if you name them, like we have x with the named ones, you can still do that thing where you just say let word, comma, num, comma, val equal x, and it'll still pull it out into the individual one. So naming them doesn't stop you from doing the pull it out by individual variable if you want. Also, by the way, in tuples, you can always put underbar for any of the names, or any of the, like here I could say let word underbar val, or let word, comma, underbar, comma, val equal x. And then I would get word and val into individual variables, and I would just ignore that middle one. Underbar in Swift always kind of means ignore that. I'm not interested in that particular thing, right? We've already seen it with function parameters when we want to ignore the external name of a function parameter. All right, so using tuples as return values, like I said, you're going to see this in the homework. Nothing special here. It's a type like any other type, so it can be the return type of a function. So this is how you can have a function that returns multiple values. Okay? In some languages, it's very difficult to do this. You have to create a structure or something to return it. Very, very, very easy in Swift. You literally just do this, right? And then when you get the value that comes back from that function, you just access the elements by name. All right? Notice that when I returned it, by the way, in my code there in getSize, I didn't have to give the names. I could, if I wanted to. I could have said return weight colon 150, height colon, but I decided, I'm just going to return the values. Okay? Okay, another thing, range. Okay, range is an important little struct in Swift. All it represents is 2 endpoints. So a range is useful for example, a selection of text, where the selection starts and where the selection ends. It's also good for a subslice of an array. Okay? You got an array of 100 elements, you might want the 15th to the 40th one. You could specify that range, 15 to 40. So range is this really simple little struct. Kind of looks like this. I say kind of. It's a little more complicated than this, but it basically looks like this. It's a generic type like array, because of course you could have a range of ints. You could have a range of floats. You could have a range of strings even. Okay? So that T right there could be float, int, string. T is restricted a little bit, and I haven't really talked about how you restrict a generic type, but that T is restricted. It has to be what's called comparable. Okay, and that's because range needs to make sure that the start index is less than the end index. That's part of what a range is defined to be. So that T has to be something that can be compared to see if the start index is less than the end index. Minor thing there. So, for example, a range of int would be great for specifying a range in an array, because an array is indexed by integers, right? Starting at 0 and going up to the number of things in the array. Now, there are other more powerful, more capable ranges, like countable range. So a countable range is just like a range, except for that you can count through intermediate values between the start and the end. Okay? It's like a range of ints. A countable range means the begin point and end point and 1 point each. Now, as you stride through that range, it depends on what the type is. Okay, striding through a range of ints is different than striding through a range of floats, okay, or striding through a range of strings. So it's a little difference there, and we'll talk about that in a minute. There's a special syntax for doing range, okay, which is ... less than or ... Okay, and ... less than means start in, and you put the start index and the end index on the either side of the ... less than. And that means go from the start index to the end index, but don't include the end index. Not inclusive of it, and the ... includes both ends. So for example, in an array, let's say I have an array of 4 strings, A, B, C, D, and let's say I want to get the C and the D out of there. I could say array sub, okay, because I'm just going to, just like I can say array sub 5 or array sub 3 is the 4th index of the array. I can also specify a range and get a subarray, a slice of the array it's called. So I can say 2 ... 3, which means index 2 in the array, which is C, because A is index 0, B is index 1, C is index 2, ... index 3, which is the D, inclusive, because it's ... And then the less than one would be exclusive. So that's why the D wouldn't be included in that one. Okay? So see how I'm using a range to get a sub-slice of an array? That's kind of cool. And by the way, if you say, give me the array from 6 ... 8, that's going to crash at runtime with an array index out of bounds, because this array only has 4 elements. Okay? So just because I'm accessing this subscripting with a range instead of with a number, it still has to be in bounds. And then if I say array 4 ... 1, that also will crash at runtime. Okay, because the range is going to look at that and say, oh, I can't create a range where the start value is greater than the end value. It can't be a backwards range. Okay, that's why that type, like int, has to be comparable. Of course, you can compare ints. One thing very important to understand, a string, a subrange of a string, is not a range of ints. Okay, you might think it is, right? I've got this string, 100 characters. You think string sub 15 to 40 would be the 15th character to the 40th, and it's not. Okay, a string subrange is a range of string.index, which is a different little data type, and I'm going to talk all about that in a few slides. Okay, but just want to make it really clear. It is possible to say string subrange, start ... less than end, but start and end are not ints. Okay, they're string.indexes, and we'll see how that works. If the type of the range that you create with ... less than or ... okay, if that type is an int, actually if it's stridable by int, if it can be strided by int, so it's not going to be floats, but I'm not really prepared to talk to you about stridable, but let's just say if the range has ints on either end, okay, so it's a range from 2 to 7, for example, then it automatically creates that countable range, that more capable range, okay? And so that range then becomes what's called a sequence. And sequences can be iterated through or enumerated, and the way you do that is with for in. So Swift's for statement, this is the only one there is. It's called for in. And all it ever means is I want to go and enumerate all the values of a sequence. Okay? And I'm going to talk about what things that can be sequenced. Countable range is one, because if an int goes from 0 to 7 and it's a countable range, then it can go 0, 1, 2, 3, 4, 5, 6, 7, right? Arrays are sequences. Sequences of their elements. Okay? So you can for in through an array. Dictionaries are also, and we'll see that a little later. So here's how you do a normal C-like for loop, for I equals 0, I is less than 20, I plus plus, okay? You cannot do that in Swift. That syntax simply doesn't exist. Instead, you would say for I in the range 0 ... less than 20. Okay, because notice I said it's less than 20, not less than or equal to 20. Okay, so 0 ... less than sign 20 means go through that. And so that little block of code is going to be executed once for 0, 1, 2, 3, 4, all the way up to number 19. Okay, so that's the same thing as what you see there. Now, what about floats? Okay, floats are a little weird. What if I want to do for I equals 0.5, I is less than or equal to 15.25, I plus equals 0.3. Okay, whoa. Okay, how am I going to do that with, for example, if I said for I in 0.5 ... 15.25, how does it know to go by 0.3? Okay, and the answer is it doesn't. In fact, a range like that, 0.5 dot 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 15.25, is not a countable range. It's just range. It only knows the start and end. It knows nothing about what's in between. So it cannot be a sequence. It can't be for-ind over. All right? But luckily, there's this great global function called stride. Okay? And stride takes a from and a to or a through, depending on whether you want to go through to the end or just to it, not including it, and a by, which is what it's going to step by. So here I say stride from 0.5 through 15.25, because I want less than or equal to, by 0.3. And that's going to create a new object. It's a countable range. Okay? Now it's a special countable range. It knows how to count from 0.25 to 15.25 by that 0.3 step. Okay? You don't worry how it implements it. Okay? Stride just creates you a countable range. Actually, this would be called a closed countable range because it counts through to the end. Okay? So it's a dot, dot, dot kind of range instead of a dot, dot, less than kind of range. And so I have a countable range. Okay, it's a sequence. I can for in it. So I say for I in stride. I'd probably say for f in, or even better than f or I. A lot of times, by the way, on my slides, I'm going to use variables like I or x or d because I want it to fit on my slide. I don't want it to be wrapping. It's hard for you to read the slides if the code's always wrapping around. So just because you see me using I and d and f doesn't mean that's licensed to have those kind of terrible names for your variables. You need to have meaningful names. So anyway, so that's how for in works here, because stride is going to return a countable range, closed countable range in this case. Okay? So that's how you do your standard for loops from C. All right, let's talk about the data structures in Swift. Okay? You've already learned about 3 of the 4 of them, which are classes, structures, and enums, right? Class, struct, enum. In our lecture, we already did all 3 of those things, right? We had a class, which is our view controller subclass. We had a struct, which is our calculator brain. And we had the enum, which is our operation. Okay? So the 4th one is protocols. And I'm not going to talk about that until next week or even the week after. Protocols are super duper important. I don't want to make it sound like they're not important, but they're new to a lot of you. And so I'm going to try and ease you in with these ones that are more familiar, although different in Swift probably than what you're used to. They're still more familiar to you. Okay? So let's just review quickly these 3 structs and what's different, same and different about them. So what's the same? They're declared very, very similar. Okay, they have a different keyword, but they're almost exactly the same. The only difference really is that a class can specify a superclass. Otherwise, they're declared exactly the same. They can all have properties and functions. Okay, so they're all very similar in that way. The only thing here is that there cannot be any stored properties in an enum. Okay, enum keeps any data it has in associated values. Okay, so it can't have any stored properties. But it could have computed properties, and they certainly all can have functions. Okay. Another thing that's very similar is they can all have initializers except enums. Enums don't need an initializer because you just say the case you want. But structs and classes have initializers. Okay, so that's the same. Now, what are the differences? Well, of course, inheritance is a big difference for classes. Classes have inheritance. Structs and enums do not. But the most important difference, which I mentioned last time, is that structs and enum are value types and classes are reference types. So let's go into that and talk about it just a little more. It's so important. I'm going to talk about it again. Okay? A value type. What does that mean? It means that it's copied when you pass it as an argument to a function. It's copied even if you just assign it to another variable, it gets copied. Okay? If you assign it to a let, it's immutable. That's very important to understand. If you assigned a value type to a let, using let x equal that thing, it is immutable. No matter how complicated it is. If it's an array or a dictionary, you can't add any elements. If it's a calculator brain, it means you can't call any of its mutable functions. So you can't do perform operation on it. Okay? Now in assignment 2, I'm going to have you add a method to the calculator brain that is going to let you use the calculator brain when it's immutable, which is kind of cool. Okay? You still wouldn't be able to perform operation, but you're going to be able to do something very important immutably. Okay? Now, because of this, okay, this kind of copyright on write behavior of value types, you must, of course, mark all the functions that are going to modify it as mutating. And that's how Swift knows, oops, I got to make a copy of this, an actual real copy, if someone writes to it. Okay? Now, a reference class is pretty different in that it gets stored in the heap somewhere with a pointer to it. Okay? And when you pass it around to a function or to assign it to another variable or something like that, you're just passing a pointer around to it. Okay? Now, and by the way, when you say let x equal a reference type, you can still send it messages that will mutate it. Okay? All you're saying is the pointer can't change, but what it points to can always be changed. Okay? Now, reference types are what you're used to. Okay? Most languages that have object-oriented programming, reference types. Reference types are a little bit Wild West. If there's a way of thinking, okay, I don't have time to teach you this. I hope you'll get to see this sometime in your career at Stanford. But there is a different way of thinking about programming than you're used to. It's called functional programming. How many people have heard the phrase functional programming? So about half of you. And the idea of functional programming is you don't want this Wild West where you've got these objects with multiple people pointing at them, any of whom could modify it at any time. Okay? That leaves you open to a lot of difficulty in verifying the correctness of your program. Okay? Whereas if you have a lot of objects that are immutable, you know they can't change. Okay? And their APIs are basically like mathematical functions where data goes in and predictable data comes out because there's not all this side-affecting data affecting other objects that someone else is pointing to and all this. It's this really well-contained little thing. Now, iOS was not developed with functional programming in mind at all, but the people who invented Swift, they were thinking about functional programming. Okay? So you can kind of mix a lot of the elements of functional programming into your application if you're building an iOS application. Now, that's a new frontier in iOS because for however long, 20 years really, or 30 years really, if you consider all the way back to the invention of the technology that led to iOS, people have been, programming with basically reference only, reference classes, reference types only for their object-oriented. But when you do programming with structs and enums, especially when you throw in protocols, which I told you I was going to tell you, they're very important, but I'm not talking to you yet, and generics, okay? When you start throwing those things all in there, you can really do a good job of doing real functional programming. Okay? Now, all of the Swift Foundation is really designed with a lot of functional programming in mind. Okay? And if you ever really want to kind of see a good example of how to apply this immutability and generics and protocols and all that stuff to build an architecture, chase down all the things that are going on in the foundation library, string and range and all these things. Remember I said things like the range is a sequence or this thing is comparable. Remember I said things like that? Okay, well how do you express that? Well, you use protocols, okay, with these immutable types, okay, these things that can be immutable, and use generics. All right, so I can't explain all that. I already spent too much time on it than I have to even talk about it in a lecture today. But just so you know, there's a huge advantage of programming kind of in a different way. It requires a real mindset change, so hopefully you'll take a class where maybe the whole class is functional programming, really you'll get a feel for it. Swift does a good job of supporting the fundamentals you need to do that. Okay? So that's kind of the long-winded answer to which do you choose, okay, if you're doing more of a functional approach. Even if you're doing a reference-based approach like you're used to, try to lean towards immutability. Try to ask yourself, can this thing work and be immutable? Is there some functionality in my program that I could share by creating a generic, for example? Okay? At least those leanings might help you build apps that are more testable, because it's a lot easier to write a test for something that's like a mathematical function where you know the data out is supposed to be the same for the data in than it is for something where there's a lot of data that you have to set everything up, set this, now call the method. Okay? That's a lot more difficult to write test cases for, et cetera. Okay, so that's value and reference. Okay, let's talk a little bit about the syntax of methods. I'm going to go fast on this. Hopefully you all understand this. All parameter names have external names and internal names, right? The internal name is used inside the definition, or inside the implementation of the function. So here I have these two functions, foo and bar. Bar calls foo. So you can see that inside foo's implementation, it is using the first and the second, whereas when bar calls foo, it uses external first and external second, okay, as the names of the items, right? And you know that you can put an underbar to make it so there's no external name, okay? And we only do that 99.99% of the time with the first item. And why do we do it? Because sometimes the name of the method and or the type of that first argument is enough to make it clear what that thing is supposed to be. Okay, so we don't need to put an external name. It's kind of clear. All the other parameters, we don't have the advantage of having the name of the method there. So that's why we almost never put underbar for the later ones. Okay. By the way, if you only put one parameter name, then that's both the external name and the internal name. And that's not that uncommon. You'll do that occasionally. Okay. All right, so you know all that. When it comes to doing overriding, subclassing, basically in reference types and classes, when you override, you have to explicitly let Swift know that you know you're doing that. Okay, and you do that by putting the override keyword. So if you override a method from your superclass, you have to say override func whatever. Okay, just make it clear. You can mark a method or even a whole class final, and that means that it cannot be overridden. Subclasses will not be allowed to override it. Okay, most languages have that. Okay, now on the topic of methods, you've seen both, but you've mostly seen and understood instance methods. Okay, these are methods or vars that are being sent to an instance of the class struct or enum. In other words, one of them. Okay, it's like I create one of them, like a double. I create a double 15.5. I have one, and I've been sending it messages. Okay, but types like the type double, the type string, the type calculator brain, they can also have methods. And vars, okay, computed vars, no storage, but computed vars, okay? And all you do to add a method or a var to a type is you put static in front of the declaration. So static func whatever means this is a function on the type, not on instances of the type, on the type itself. So let's think about double, for example, here, okay? Double actually has quite a few static or type methods and vars, okay? You access them by sending the message to double, to the actual word, capital D-O-U-B-L-E. You don't send it to an instance, you send it to that word. And you've already seen at least one of these, which was pi. Okay, remember we said double.pi and we got the value of pi? So pi is a var, a computed var, on the class, or the struct actually, double. Okay, but it also has other methods like abs. Abs takes a double value and returns the absolute value of it. Okay, that is on the type. You say double.abs, double.pi. Okay, as opposed to, for example, if I had a double, like I let x equal 23.85, so x is now a double, I can't say x.pi because x is an instance of a double. You see the difference between saying x.pi, trying to send pi to an instance, versus sending pi to the type double. Okay, so what do we use these type methods for? Well, we can't access any instance variables because we're not sending them to an instance, so we mostly use them for utility methods, things like that. Okay, constants like pi is a good example. Things that kind of are functions that are associated with this type but don't belong to a particular instance or wouldn't really operate on an instance. Now, for example, you might have an instance method or even an instance var called abs, ABS, with no arguments. That you would send to an instance, and it would take the absolute value of the thing you sent it to. Okay, but of course the type one has to have an argument because you're sending it to the type double, so there's no double involved. There's no instance of a double involved. Okay, we got that? Alrighty. Properties. Okay, so you know all about properties, right? We saw computed properties like display value in our calculator. There's actually some really cool features on properties. One of the most interesting ones is property observers. Okay, so what is a property observer? A property observer is a little piece of code that will get executed when your property changes. Okay, so anytime your property changes, this little piece of code can get executed. Now, you can actually find out just before your property changes, or you can find out just after your property changes, or both. Okay? And the way you do this, and this works for your stored properties, okay, like user is in the middle of typing, we could put a property observer on there and execute some code every time we change that. Okay? It also works for inherited properties. So if you inherit something from your superclass, you can put these property observers in and notice that it changed. All right? By the way, if you have a property which is a value type, okay, a struct or something like an array or a dictionary, This property observer stuff will happen if that thing gets changed, if it gets mutated. So if you add something to the array, boom, the property observer will kick in and say, oh, that changed. So how do these property observers work? They look a lot like a computed property. Remember a computed property display value? We had get, and then we had some code, and then we had set, and we had some code. Okay? This is similar, except for instead of get and set, it's will set or did set. Okay? Now, by the way, you probably would never, I don't even know if you can use this in a computed property because you've got the set clause there, so you can just put it right in set. You don't need to find out when it's set because you set it. Okay? But for stored properties and inherited properties, it makes sense. So you have will set. Now, will set, first of all, you put it in a curly brace after the property, just like if you were doing a computer property. But this is not a computer property. Just because I put the curly brace doesn't make it a computer property. I have to put that get or set in there. But if I put will set, then inside that code, there's a special variable, just like there is in the set case of computer property, called new value. And that is the value that that thing is going to be set to. It's not set yet. Some property, see some stored property up there? It has not yet been set to new value, but it's going to be. And then did set, that code is after some property has been set, and the special variable in there is old value. That's the value it used to have before it got set. So you can compare. Okay, you compare if they've changed, for example. All right? So where do we use these things? Probably the number one place we use them is in our controller in view. When something changes, okay, like let's say I'm a button and my background color changes, I inherit my background color from my superclass, UI view, one up the chain of superclasses. Every time the background color changes, the button wants to redraw itself. So it will have var, background color is a UI color, open curly brace, did set, open curly brace, draw myself, close curly brace. Okay? Question? Oh, okay, so the question is, if someone changes some stored property there, am I responsible for doing something about that in will set or did set? Do I have to actually set it? And the answer is no. Okay, that's being set somewhere else. You're just getting a chance to run some other code that you want to run just before and just after it happens. But you're not responsible for setting the actual value. That's done for you. That's why you get to see the old value and the new value in the two of them. Okay? So we'll see this next week when we start drawing on screen, where we're going to be watching properties change so we can cause ourselves to redraw. Okay, lazy properties. Okay, so lazy initialization is a really powerful tool. Okay, it's going to get you out of a lot of binds in this class. What does it mean? A lazy var, a var that you say lazy in front of, okay, whatever it's set equal to, that equals doesn't actually happen until someone accesses that var. Okay? Until someone asks for the value of that var, it doesn't actually do the initialization there. It doesn't do that equals something. So it's lazy. It's waiting. Now, why do you want to be lazy? Well, one obvious reason is, like here, lazy var brain equals calculator brain. What if our calculator brain was really expensive to create? What if it opened a network connection because it was going to share the calculations with the internet or something? You know what I mean? It did something that's expensive. Well, you wouldn't want to do it until someone actually created, tried to access the brain. It's called set operand on it or something. Then you would want to actually do the work to create it. Okay, so one reason to be lazy, it's not that important of a reason it turns out, but one is to delay expensive operations. Okay? But what's another reason to do it? Well, in Swift, all vars have to be initialized. Remember that? Remember we added users in the middle of the typing and we didn't say equals false and we got an error. It said we had no init, right? Because we hadn't initialized that. Okay? Well, not only do they all have to be initialized, but they all have to be initialized before you can even send a message to that class, even internally. Okay? So you can't invoke any of your own methods until you fully initialize yourself. What if one of the things you want to initialize needs to call a method on yourself? Okay? It's impossible. Because if you need to initialize something to be allowed to send messages yourself, and you need to send a message yourself to initialize something, it's a deadlock. You can't do it. Okay? Well, lazy lets you do it. Because you can say, for example, the last one there, lazy my property equals some method on myself. And this is not going to be executed until someone tries to access my property, and no one's allowed to access my property until I'm fully initialized. So by definition, there's no way that that is going to try to get initialized until I'm already fully initialized. And yet, this lazy thing counts as this thing having been initialized. Okay? So this is the big loophole. Lazy-var my property counts as having been initialized, even though it really hasn't yet, because it's waiting for someone to actually access my property. Okay? But it counts, okay, for the purposes of that rule. So now someone comes along later and accesses it. Now we can call this method. So do you see how deferring the calling of this method in order to initialize this gets us around that requirement that everything be initialized? Okay, so it's really tricky. And then the middle one there, some property, that's super tricky because you can actually have a closure. Remember what a closure is, right, from calculator brain? It's just a function, inline function. You can actually have a closure to initialize your thing lazily. Okay, and all you do is you put the closure, open curly brace, close curly brace. It obviously has to return something of the type of that var. Okay, and then you just put the little open parentheses, close parentheses at the end. You see that? That when you put open parentheses, close parentheses at the end of a closure, that means execute this closure right now. Okay, but it's not going to execute right now. It's going to execute it lazy, so it's going to happen later. Got it? And that means that that closure inside could reference self, because self will be fully initialized by the time this closure gets executed, since it's lazily executed. You got all that? So lazy will get you out of some of these tricky wickets, because when you see me talk about initialization, you're going to be like, I don't want to do that ever. Okay, you're going to be trying to avoid it, and this is a good way to avoid it. Okay? So yeah, it still satisfies all those things. All right. On to array. Everybody knows what an array is. Everyone knows what a generic array is. When you declare the array, you have to say what type of things are going to be in the array. There's a different syntax, though, which I didn't introduce when I did dictionary in the demo. But you can declare an array. Those two yellow things up there are exactly the same thing. So open square bracket string, close square bracket is exactly the same as saying array, angle bracket string. It's just kind of a special way to declare an array. And it actually seems to be the preferred way. I actually prefer the other way because it's a little clearer to you who are learning that this is an array, because it says the word array and string. But, you know, open square bracket, close square bracket, we know that's the way we index into an array, so it looks kind of array-ish, but just get used to it, okay? Open square bracket string, close square bracket means an array of string, okay? It's the declaration of that. That's the name of that type, array of string. So if I had a string right here like this, giraffe, cow, doggy, and bird, okay, 4 animals in here, 4 strings, and I said animals.append ostrich, well, appends something onto the array. Now, the thing you're appending has to be the same type, obviously, as the type of everything in the array, however the type was declared. Notice that animals is inferred by Swift to be an array of string, because Swift sees that you sent it to an array of things, and it looked at all the things, and they were all strings. So it said, oh, the animals must be an array of string. Now, this line of code, animals.append ostrich, that's very bad. Can anyone tell me why that's not going to work? Yeah? There's a let. If I was Mayron, I'd be throwing candy at you over there. That's exactly right, okay? We define this let variable with, or this animals variable with let. So it's immutable. So when we say append an ostrich onto an immutable thing, it's going to crash my program. Actually, it won't even crash my program. It won't even compile. The Swift compiler is just going to say, no way, you can't do append of something on there. So that's a good one over there. You got that. All right, how about this one? I'll give you a second chance for everyone. Why is this one no good? Okay, I'm trying to get animal sub 4 over there. Why? Nobody. This is easier. Array index, more candy. Array index out of bounds, exactly, because arrays are indexed starting at 0. Okay, so giraffe, cow, doggy, bird, that's 0, 1, 2, and 3. So if I say, give me array number 4, bam, crashes my program, array index out of bounds. Okay? All right, let's talk about the fact that array is a sequence. Okay, array is actually a collection, and collections are sequences. And a sequence means I can do for in on it. So if I say for animal in animals, my little for loop will get executed 4 times. Once with animal being giraffe, the next one with animal being cow, the next one with animal being doggy, and the next one with animal being bird. Okay? So that's a really cool feature. Remember, this is the only for there is in Swift. For in, that's the only for there is, nothing else. I have time for this, I think. So array, in a lot of classes and structs in iOS, have some interesting methods that have arguments that are closures. Okay? So I teach closures to you right at the beginning of the quarter. And why do I do that? Because closures are an important thing to understand if you want to really use the iOS API well. So let's take just so we can learn a little bit about how closures can make our API great, okay? Especially, again, if you're doing functional programming, closures can be really good for that. But why are closures so great? So let's look at this. So this first function right here called filter is an array method. It's just array, func, and array. Okay, nothing special about it. It's just func and array. It has one argument, okay, which is called include element. And that argument is a function. It's a function that takes one argument, which is of the same type as the things in the arrays. Okay, because it's a t, so I have an array angle bracket t. It's a generic type. So this function is declared in that generic type. So the t means the same type that's in it. So if I have an array of strings, this filter expects this to be a function that takes a string as its only argument. And it returns a bool. Okay, so that's the argument. The argument is a function that takes a string and returns a bool, or takes a t, whatever that is, and returns a bool. Okay? And then what's the return value of this filter thing? It's an array of t, so another array with the same kind of elements. Okay? So what does filter do? Filter takes every single element in the array that you're sending it to, and it runs that little function. And if that function returns true, it includes it in the array it returns. If it returns false, it doesn't, throws it out. So it's a filter. It's filtering your array and creating a new array with all the things you don't want, as defined by this function that you're providing as an argument, with all those things you don't want thrown out. So for example, here I have this var that I'm creating big numbers, and I'm creating an array on the fly, 2, 47, 18, 118, 5, 9. See, I create an array, and look what I'm sending it a message right away. Okay, I didn't even have to put it into another var, by the way. I could have, but I just want it all be on one line here. Okay, so I created this array, and I'm sending it the message filter, and look what I'm providing for the argument there. Okay, that include element, it has an underbar, so you don't have to actually put the include element colon in there. All right, so what am I putting in there? That's a closure, right? So that means it's a function. Okay, now Swift knows that this is a function that returns a bool, so I don't have to put the word return in there. Okay, I can use $0 to be the one and only argument to the function. Okay, and I'm just going to check and see if $0 is greater than 20. In other words, is this a big number? Okay, so I get back an array which has only 47 and 118 in it because I've filtered out all the things where the value is not greater than 20. Okay, so do you see how this one line of code, imagine writing this line of code without filter. Okay, you're going to have to do a for loop, you're going to have to create another array, you're going to have to run this little function, call this function, create a new array and append things to it. It's at least 4 or 5 lines of code. And here you get it in one line of code. Okay, so you see how closure there has helped us kind of define. This is also much more readable because you can read this like this. Let the big numbers equal this array, but filter for things that are greater than 20. Okay, that reads nicely. It's clear. It's very easy to understand what's going on here. Okay, so here's another one. It's called map. Okay, what map does, it takes a closure or a function, okay, and it executes that function in order to transform each of the elements in the array you're sending map to a new array. Now, that transformation can be anything that a function can do, and you can convert it to any new type you want, although the function, it's one function, so it all converts everything to the same type. So you could use it for type conversions like I have here. I've taken 1, 2, 3 and mapped it to the string versions of 1, 2, 3. So now I have a new array with strings in it. String of 1, string of 2, string of 3, right? That's a trivial mapping, but you can imagine much more powerful mappings where you take each element of the array and call some complicated function on it and get the result into a new array, okay? And so by creating a really powerful argument there instead of string $0, something more powerful, you can really have one line of code that's really expressive, okay, and doing a lot of things. One thing about this one also, notice that after the word map, see, there's no parentheses, no open parentheses. Do you notice that? You see the difference between filter and map? Okay? When I called filter, I said open parentheses, open curly brace, the function, curly brace, close parentheses. Here I just say curly brace, string $0 and curly brace, no parentheses. And this is what's called the trailing closure syntax. You are allowed to have closures that are the last argument to a function be outside of the parentheses of that function if they're trailing. See, they're trailing the call. And in fact, if there's only one argument and it's closure, you don't need the parentheses at all. And that's what's happening here with map. I'm just saying map, parentheses, get rid of them. Just put the closure there, trailing. Okay? And that also results in some pretty cool looking code right here. You see that? So you can use that anywhere. Anywhere that a closure is the last argument of a function, you can take it outside to put the curly braces, because you already got the curly braces. That's why they do it. You don't really need the parentheses around it as well. Just put that at the end. And put all the rest of the arguments, if you had them, inside the parentheses right before. This last one, I won't go into the details, but it's a similar kind of thing, reduce. What reduce does is it takes an entire array and reduces it to a single value. Okay? So here I'm reducing it by adding all the numbers in the array up. So my closure is $0 plus $1 because the argument it takes is a function that takes two elements. One of them is an element from the array, and the other is the answer so far. And then it returns the new answer so far. So it just executes that function over and over and over on the arrays. By the way, notice I can say this as sum equals 1, 2, 3 dot reduce 0, which is my starting so far value, which is I haven't added any up yet, so it starts at 0. And then I can say plus. And the reason I can say plus right there, that bottom line, is because plus in Swift is not some kind of weird built-in thing. It's just a function. Okay? It's a function that happens to be declared in a way that says this is a function, but its two arguments go on either side of it. Okay? It's called an infix operator, function. So since plus is just a function, and I'm taking a function as an argument, as long as it's a function that takes two arguments and returns one, which is exactly what plus does, it works there. We could have done that in our calculator brain too. Remember all that closures we were doing? Closure $0 times $1, that could have just been star. Closure $0 plus $1, that could have just been plus. Okay, because plus is a function that takes two doubles and returns a double. Got it? Plus also knows how to plus other types, ints, and even knows how to plus an int to a float, for example, etc. You can plus strings together. Okay, so that was just a little aside, just to give you an introduction there. Look, when you see in iOS, you're going to start seeing a lot of methods that take functions as arguments. I want you to start to get comfortable with that. Okay, dictionary. So you learned a lot about dictionary in our first lecture. Dictionary also has this special declaration syntax, which is open square bracket, key type, colon, value type, close square bracket. Okay? So those two things in yellow are equivalent. And the one on the bottom seems to be the preferred one these days. Okay? So you know you can create a dictionary. By the way, I show you creating dictionaries from kind of constant values here, but you can create a dictionary just by saying let d equal dictionary, open parentheses, close parentheses. And if you say var d equals dictionary, then now you can start appending items onto it because you get an empty dictionary to start. But here I'm starting my dictionary with stuff in it. Probably should say var Pac-12 team rankings because 2 lines later I say Pac-12 team rankings sub-cal equals 12th. Okay? So note also that when I try to get the ranking of Ohio State, it returns nil. And we know that when we use square brackets to get something out of a dictionary, it returns an optional of our value type. Okay, our value type here is ints, so it's going to return an optional int. Okay? Everybody got that? All right. Enumeration. Okay? A dictionary is also a collection and thus can be sequenced. So you can do for in on it. Of course, a dictionary has keys and values. So we need a tuple to do our enumeration for the tuple key comma value in the dictionary. And then it'll go through and key and value will be set. Now that makes sense. Perfectly straightforward way to enumerate or iterate over a dictionary. Okay, string. So string, you would think, is the simplest class in all of any language. It's just a string, right? Well, that turns out not to be so true. Okay? When you think of a string that represents every language in the entire world, all of a sudden it got real complicated real fast. Okay? Because some languages are ideographic. Some languages go right to left instead of left to right. Some languages have a lot of diacritic marks and accents in them. Some don't. Okay? Most languages don't use the same alphabet as we use. Okay, so string is super complicated. This is a very complicated class. Now, string tries its best and does a pretty good job of simplifying it for your use. But the complexity is still there. Now, the most important complexity about a string is that representing a string is not always one character equals one internal representation unit. Now, the units, the kind of thing that's used to represent strings on the inside are Unicodes. Okay, I had you skip that reading in assignment 1. I'm putting it in for assignment 2. It's really not that critical that you understand it. I think it's very interesting though, so you probably want to read it. But the thing about Unicodes is it's not one Unicode equals one character. In fact, if you have like a little emoji of a dog barking, that might be 3 Unicode characters, is one what you perceive to be a character. Or even more simply, the example I have here, the word cafe. It's got accent aigu on the end, right? It's a French word, accent aigu. That could be 4 Unicodes because there is a Unicode for accent aigu, or it could be 5. It could be the E with another Unicode character that says put an accent on that previous character. Okay? So when you have this kind of unknown how many characters it represents, you need a new abstraction to represent what we perceive as humans to be a character. Even that is difficult to truly define when you think of all the languages in the world. It's easy in English, though. So that's really how we're going to interact with strings, is try to think of them in terms of characters. But a string itself is not actually a collection of characters. A string is a more powerful internal, it's got all the Unicodes in there and all that stuff, so it's not quite that. And that makes for a little bit of complication, as you're going to see. Now, string is indexable, which means you can use the open square brackets, just like you can in an array, to get one of the characters. The only rub is what I said on the other slide, that index is not an int. So if you have the word hello, it's not like you can say, hello sub 2 or hello sub 1, let's say, equals E. Okay, you can't do it that way because it might, if it was cafe, then cafe sub 3, it's not clear what, you want a character at that point. And so you've got to make sure you get the right index in there. Because that index behind the scenes can be quite complicated, there's this other struct for it, which is called a string.index, okay? So let's say I had a string, which I'm going to call S, and I'm going to put hello into there, okay? Now, what if I wanted S sub 0, basically? Now, I can't do S sub 0 because we don't index strings by integers, but let's say I want that. How do I get it? Well, I start by calling this var, using this var on string called startIndex. Okay, it gives us a string.index. It's very important we need to get a hold of a string.index because the way we're going to move around in string is by taking an index we know and moving forward or backwards by character, by human understandable character, not by Unicodes because we don't know how many Unicodes there are per character, but by character we're going to be moving back and forth. So we're going to start with the first one. And so now I can create a variable firstChar, which is of this type character, that's human understandable character. And that's going to be equal S sub first index. So see, look, I've used square brackets to index into a string, but I've had to use a string.index, not an int. Right? I use this first index thing I got by asking the string, what's your first index? Well, this is kind of useless because I have to ask the string, what's the index of your first character? And then turn around and say, okay, give me S of your first character. So that's not the interesting thing. What if I want the next character? Okay, if I want the next character, I ask the string, what's the index of the character after your first character? Okay, and it'll give me a new index of its second character, and now I can get that one. Okay, even that is a little bit like, oh my God, you're kidding me. This is really how I have to do this? What if I wanted to go jump ahead, though, and get the fifth character, let's say? Well, I can jump ahead by saying S, give me the index of starting at your first index that's 4 ahead. So jump 4 ahead, 4 characters ahead. Okay? So this is all a little tedious. And of course, this is not the actual way that we're interacting with strings. We're usually looking for substrings, okay, or subranges of characters, or we're trying to find a character in a string. So let's talk a little. Oh, by the way, you can use ranges. So I could say, give me the substring, which is first index ... second index, and it would give me HE, okay, a new string, which is HE. So you can use ranges there, but they have to be string.index, not ints. Okay, so we want basically something that is a collection of characters. Okay, a string is not a collection of characters, so you can't do for in, for example, on it. You can't even say index of. Okay, index of is this great thing where you can, if you have a collection of things, you can say, give me the index of this thing in there. Okay, you can't even do that with a string because it's not a collection. Okay, luckily, string has a var which will give you a collection of its characters. And not only is it going to give you a collection of its characters that you can for in over and do index of, but the string indexes you get from that collection will match what's in the string. Okay? So you can use this collection of characters to find things in there, get the index of a character, things like that, and then use the indexes you find there to go back to your string and say, okay, now give me a substring. Okay? So characters is the name of this var on string. So for example, if I want to iterate over all the characters one by one, do a for loop over them, I can say for c, which will be of type character, by the way, in s.characters. I can't say for c in s, for c in s.characters. Okay? And that's just going to call my for loop once with each character. Question? Yeah, great question. So if I do this over cafe, what am I going to get? I'm going to get 4 characters. Okay? Because that ex I'll take u is considered, in our human perception, 1 character. I'll get 4 characters. So there is a character. Character is a struct, right? And there's a character that represents ex alpha u. No matter how it's represented in the string. In the string, it might be 2 characters, it might be 1, doesn't matter. You're going to get the 1 character for it. So that's a really good question. Also, how do I know how many characters there are in a string? Again, from the user perspective. s.characters.count. Not s.length or something. s.characters.count. The count of the characters in the collection of characters for this string. Also, what if I want to find the first space in a string? Got a string with a bunch of words. I want to find the first space. I would say s.characters.index of space. And that's going to give me a string.index of space in that collection of characters. I can then use that string.index, though, to go back to my string and do something. Maybe insert something there, or delete the word that's right after the space, or insert another space. You see what I'm saying? I'll have the index into the string now. Okay? Now, string is a value type. Okay? So when you do let versus var, if you do let, you cannot do things like append onto the string because it's immutable. Okay? Most strings in Swift are immutable. That makes it super high performance. Okay? But if you have a var, you can do greeting plus equals there, and so I can have hello there. Doesn't have any effect on hello, the let one, because that's immutable, right? Okay, so I can do that. And I can use the characters to manipulate strings in really powerful ways. I don't have time to talk about all of it. This is where you really do need to read your reading assignment carefully. But for example, if I want to insert the word you into hello there, so it says hello you there, okay, I would just find the first space by doing characters index of space, which I showed you on the previous slide. Then there's a method in string called insert the contents of this collection of characters at this location, this string.index. So when I want a collection of characters that represents space u, I say space u dot characters, because it's the dot characters thing that gives me a collection of characters for that string. Okay? So it seems a little weird, but it actually turns out to work out pretty well. And there's a billion other functions in Swift, many, many, many. I can't talk them all. Notice I say if let first space, because that might return nil if it couldn't find it. So I wouldn't do it there. I wouldn't insert it there. Okay, and yeah, a bunch of other things, checking where strings have prefixes or not. You can replace subrange. Of course, you have to find the range, which usually you're going to have to look at that collection of characters to find the ranges you want to replace things, etc. Even cool methods like component separated by string. We'll take a string that has like comma separated values and grab all the values and put them in an array. It's kind of fun. Okay, so string has dozens and dozens of methods. You really need to familiarize yourself. If you don't take the time to familiarize yourself with those things in string, then I guarantee you're going to be writing a program and you're going to want to do some string parsing or something, and you're going to write a whole bunch of code to do it, and then find out there was one method that did exactly what you want in string. Okay? So, and there are things in there to take closures and do all kinds of fun stuff, so make sure you pay attention to both to string and to the character view, which is that collection of characters. All right. Other classes. Okay, this is kind of quick summary here of other important classes. One is NSObject. NSObject is a class It is the root of all Objective-C classes. Okay? An iOS app written before a couple years ago when Swift came out, all the classes in there would inherit eventually from NSObject. So NSObject kind of has some base functionality. You do not need to subclass from NSObject to make a Swift class. However, there are some really obscure features still left in iOS where it's expecting a class that inherits from NSObject. I'll show them, if we even get to them, I'll show them to you. They're pretty rare, but that's just so you know what NSObject is. It doesn't really have any meaning to you because you guys are going to be Swift programmers. NSNumber is another class. It's a generic number holder. Okay? This is also inherited from Objective-C. You can tell by the NS there. And so it can hold any kind of number, floating point, decimal. It can even hold a bool. It considers that a number where 0 is false and 1 is true or whatever, or non-zero is true. And it can also do type conversions. Okay? Again, in Swift, we're going to be using the actual concrete number classes like double and int, and we'll use their constructors to do type conversion. But just so you know that NSNumber is around. Okay, date, super important class. Anytime you're representing a date or time, you're going to want to use this date struct. Okay? And it has a lot of ancillary classes that go with it, like calendar, date formatter, date components. Like date components will tell you the month of a date. And of course, what the month is of a date depends on the calendar it's in. Okay? Because not everyone uses a calendar like we do. All right? There's a lot of calendars all over the earth that are different than ours. So anytime you're even contemplating putting a date anywhere in your UI, you need to be using this class. Okay? Because if you want to have your app work in anything but English, you're going to have to format your dates using the date formatter in whatever locale your app is running in. Okay? So date is super important. You would think date is really easy, but no, date actually has a lot of complexity to it because of all the different ways we represent dates in the world. Similar to strings complexity. And then there's data, D-A-T-A. That represents a bag of bits. Just a bunch of bits in there. Usually this might be something like an image, the bits of an image, or something like that, something you get over the network. So data is how we represent those. Notice that it's a struct, it's a value type, it gets passed around copy on write. Okay, that's important to know. And you'll start seeing data in the UI maybe week 5 or 6 of this class. All right, initialization. So initialization is very complicated. You're going to have to read the reading assignment on it eventually. I'm going to give you the really fast highlights of it. Okay? Init method, again, we can have them on classes or structs. They are used to initialize any of the properties that we didn't initialize with equals or using lazy or they were optionals. Okay, all those are taken care of, and if there's one left or more than one left, then we need an initializer, okay, to initialize it. And they're kind of a pain in the neck because, especially for classes, for structs, they're not a pain in the neck. They're perfectly fine. Struct, you just have an init with whatever arguments you want and initialize your variables. It's all very, very simple. But for classes, it's a little bit more complicated. Now, whether you're a struct or a class, you can have multiple inits and they can have different arguments. Okay, as long as you give them enough arguments to be able to initialize all their variables, you're good to go. So you can have as many inits as you want. And a lot of classes have multiple inits, depending on kind of how they're being used, how they're being created. Think of something like string. String has an init that takes a double. It has a string that takes another string, if you want to make a copy of a string, it turns out. It has an init that takes an int. It has all these things that you can convert to string, or not all the things you can convert to string, but a lot of the things you can convert to a string. It has an initializer that will take that as an argument, for example. Callers execute your init by creating one of your thing. Okay, they just put the name of the type and parentheses and the arguments you want for that init. Okay, so they pick which of your inits they want and they call that one with those arguments. So we've seen many examples of this in our lecture so far. Right? You get some inits for free. Okay, if you're a base class, okay, you don't inherit from anything else, you get a free init with no arguments. Congratulations. Okay, so that means at least people can create you. But again, if you have any vars that aren't initialized, you're going to have to create your inits that initialize them. Structs, even better, they get an init that has all of their vars. Okay? Now, if a struct implements even one of its own initializers, it stops getting this one, this free one. You only get the free one if you don't do any other ones. Okay, so it's like the default one. And we saw this in the lecture also. We got the free one, init function first operand. Okay, we never wrote that init function. We got it for free. It just appeared, and we were able to call it. Remember that? Okay, so structs are nice. You get the free, basically free init for all your vars. Okay, what can you do inside of a init? I'm going to start going fast here. Okay, so here we go. One, you can set any property's value. Even if that property already had its value set, you can reset it to something else. You can set lets. Okay, so even if you have a let that's got lets x equal 5, you can still reset it in your init. Your init is allowed to set lets. Okay, you can call other init methods. Okay, in your own class or your own struct. And you do that by saying self.init with whatever the arguments to that init method are. So the init methods can call each other. In a class, you can call superinit, okay, an initializer from your superclass. Of course, you need to get your superclass initialized. Now, when we start talking about class, though, and we start to talk about calling inits in our super, and we start thinking about inheritance, it gets really complicated, okay? So let's start thinking about class and break this down. Let's start with what are you required to do in an init for a class? Okay? In a struct, it's easy. You're just required to initialize all your vars that aren't initialized. But in a class, what are you required to do? Okay? By the time it's done, you have to have initialized all your vars. We know that. There are two types of initializers. A convenience initializer. This is only for classes. A convenience initializer and what's called a designated initializer. Designated is the default. There's no keyword. It's just if it's not marked convenience, then it's a designated. Now here's where the rules come in. A designated initializer, non-convenience, must and can only call a designated initializer that is in its immediate superclass. This is very important. Okay, it has to call a superclass init, and it has to be a designated initializer. It cannot call a convenience initializer in its superclass. Nor can it call two classes up the inheritance chain unless the one right above inherited the init from the one above, and we'll talk about that in a second. You have to initialize all of your properties before you call that super init. Okay? You must have completely done all the ones you introduce in your class, get them initialized before you call super init. And you have to call the super one before you can reinitialize or change the value of any of its properties. Obviously, you got to let your superclass have a chance to initialize itself before you start mucking with its properties. Otherwise, when you call super, it's probably going to blast whatever you did to its properties. Okay? A convenience init can only, it must, and can only call an initializer in its own class. No super. Okay? Only in your own class. Convenience initializer only in your own class. Got it? You can call it another convenience, or you can call it designator, but it has to be in your own class, not in your superclass. All right? And a convenience init has to call whatever init it's going to call in itself before it can set any of the property values. Okay? It's kind of different from an init that calls into super, because that one has to do its initialization, a designated one, before it calls super. In this case, you have to do convenience. You have to call your other one first. And the calling of all other inits, whatever you do, okay, any inits that you have to call, has to be done in all cases before you start calling methods on yourself or accessing properties. Not setting the properties, but accessing them. In other words, you have to be fully initialized before your init can start using your class. Okay? All right. Whew is right. Okay, a lot of rules there. And a lot of them are conflicting and all that stuff. And let's make it even more complicated when we talk about inheriting inits. So you want to get some inits from your superclass. Whoa, not so fast. If you don't implement any designated inits, you only implement convenience inits, then you will inherit all of your superclass's designateds. But only if you don't implement any of them. If you implement even one designated init, now you're not going to inherit all your superclasses. Okay? If you override all of your superclass's designated inits, then you'll inherit all of its convenience inits. Okay? Now, why is that? That's because your superclass, when it implements these convenience inits, it depends on the designated inits being implemented, so you have to implement them all. Of course, you could inherit them all by implementing none of them as well. Okay? So any init that you inherit by these rules can be used to satisfy any of these other requirements that we're talking about on the previous stage. You can make an init required. You just say required init. Okay, required is a keyword. And that will make it so the subclass has to implement that init. Okay, it's required. Failable inits, we talked about these with double. Okay, if you put a question mark after your init question mark, that means that this init can fail. And that means that this init, or when you create this thing, will return an optional version of this class. So we saw that with double, right? If we said double parentheses string, it returned an optional double. It was a failable init. And that's because you could have said double of hello, and it'd be like, I can't turn in a double. Fail. And the way you fail out of a failable init is you just return nil. Okay, otherwise you don't return anything out of init, it just initializes. But the one time you return anything is out of a failable init, you can return nil. So an example here is UI image. UI image named looks up that image in the XC assets. Remember that XC assets thing that I moved off to supporting files at the beginning of the first demo? This looks it up in there. Of course, it might not find it. So we do if let image equals UI image named foo, then we do something. Otherwise, we fail. That UI image initializer failed. Okay? All right. Any and any object. Okay? This is no more init. We're done with init. Okay? Any and any object. These are types. Okay? Special types. These types really are almost exclusively used for backwards compatibility with Objective-C, because Objective-C had a type in it called ID, which was kind of like any object, actually. And so Swift needed some compatibility, but Swift doesn't really use any very much, so we wouldn't. Swift is strongly typed, so you wouldn't want to have a type which is like, it can be anything, okay? Because that's what any and any object are. It's like anything, any type. It's this weird kind of typeless type kind of thing. The only difference between any and any object is any object can only be a class. It has to be reference type. Any can be anything, reference or value type. That's the only difference, okay? So why do we have these any object things? Where are they going to show up? Well, there are some methods in iOS where one of the arguments truly could be anything. Okay, one example here is when you have multiple MVCs, which we're going to learn about next week, the way you go from one to the next is called segueing. You segue from one MVC to the next. And the thing that causes a segue to happen, okay, is the argument in this method called prepare for segue, called sender. Okay, just like we had sender in the IB action. So the sender is the one who's causing this segue to happen. Well, a button could be causing a segue to happen. A line in a table view could be causing it. Some custom piece of code of yours could be causing this MVC to segue. So when you're preparing for it, you got to be able to say which one it was, and that's just any. Okay? So if this were a Swift API, they wouldn't have done any. They'd have had a protocol where you could be a segue sender. Okay, and you'd have to implement probably some functionality that would make sense here, okay? But in this case, it's any. It's known as optional any too, because you can have nil. A sender could be nil. Where else will you see it? You could have an array of any object, or array of any. That could be an array that has doubles and strings and things mixed in there. Now, you might be tempted to use this in your assignment number 2 when you see the assignment, but you're not allowed to because one of the required tasks says you can't use any or any object. Okay? Also, it wouldn't be very Swifty. In Swift, if we wanted to put doubles and strings in the same array, we use an enum. That's what we did with our operations array, and that's what we would do in Swift. So we wouldn't use any object. Okay, another thing you could possibly use any for is for a cookie, right? Some piece of data that you're giving out that you don't want people to know what class it is. And they're just going to give it back to you at some point, and you'll do something with it, and only you know what it is. So, you know, an opaque type, you could use it for that. So how do we use something of type any? Okay, because we can't send any messages to it because it's not of any type, so we don't know what any methods it does or whatever. Instead, we have to convert it. And we convert type any, or any object, into some class that we know about using as. Okay, as is a keyword. We do as question mark because we don't know for sure that we can convert something, so it's an optional. And we use it with if let. So if I had some variable unknown, which is of type any, so I don't really know what it is, but I think it might be my type. I'm not sure, but I think that might be my type in there. So I can say if let foo equals unknown as my type, if let, right? Then inside there, foo is now going to be unknown, but as my type, okay? And so I will be able to send foo message, whatever my type, I'll be able to send foo whatever my type understands, methods and vars. Got it? So that's how we use it. We use this as. It's called casting. This casting, by the way, not just for any object. We can cast other things. For example, if I had a variable which is a VC, which is a type UI view controller, I could assign it to calculator view controller, because calculator view controller is a subclass of UI view controller, so it is a UI view controller, so I could assign it to VC. But if I assign it like this, with this typing, I cannot say VC.displayValue. Because VC.displayValue is a var in calculator view controller, and VC is of type UI view controller. Even though it points to a calculator view controller, from Swift's perspective, it's typed as VC, and Swift is strongly typed. Okay? So if I wanted to send display value, I would have to say if I can let calc VC equal VC as a calculator view controller, now I can send display value to calc VC. You see? Because it's the type that you actually type it as that matters, not what it's pointing to. So you have to use as to get it to be something that you really want to use. Okay? I'm going to go a little bit over here. If you have to go, it's fine to keep it quiet. The last thing I'm going to talk about is user defaults. User defaults is a very lightweight, limited database. Okay? It's a tiny little database that persists between launchings of your app. It's great for things like settings and stuff like that. Don't put anything big in there. The only thing you can put in this database is what's called a property list. A property list just means any combination of array, dictionary, string, date, data, or a number, like int, float, double, whatever. Okay? That's what a property list is. It's just conceptual. There's no actual type property list, unfortunately. If this were a Swift API, it probably would be such a type. It'd be a protocol. But anyway, there's not. This is from Objective-C. Okay? So since there's no type that represents that hodgepodge of classes, okay, this API that I'm going to show you, user defaults, uses any. Okay? And this is what it looks like. It has this core set and get. Okay? Set, any. Now that any can't really be any. It has to be one of those types, string, dictionary, array, whatever. It has to be a property list for key string. So you just put anything you want in this database under a certain key. And then you get it back out by saying object for key, and it returns you an any. And it's an optional any because it might not be in the database, in which is return nil. Okay? So that says any, but it's not really any. Okay? It's any as long as it's a property list, which means it's one of these 10 classes or whatever. Okay? And the way you read and write it, you don't create a user default by saying let x equal user defaults with parentheses. You say let defaults equal user defaults dot standard. So that's a type var on the user default struct. Okay? And you get this standard user default, and then you can send it things like set, that thing I was telling you, set any. And here I've got 3 different sets, one of them setting of double, one setting an array of ints. An array of ints is okay because array is part of property list, and so is int. So that's okay, that's a property list. An array of ints is a property list, so is a double, because it's one of those types. And I just set them in there. And then when I get them out, I use that object for key. And actually for some common types, like doubles, arrays, and dictionaries, there's actually a nice little method in there to give you that type back. That's so that you don't get an any back and then have to do as, right? Because you know that object for key returns an any, and so you get this any, and you have to go, if this thing as a double, then I've got it. That would be annoying. So instead, it just has a method called double that does that as for you. And if the as fails, then I think either, I don't know if it returns a double or an optional double, but you might get 0 back, you might get a nil, I don't remember exactly. But for array and dictionary, a couple interesting things to note. Obviously, the any's that are inside the array and dictionary, those will have to be property lists as well. Okay, the things that are returned to you. And also know that dictionary, this convenience method dictionary, the string is always the key in the dictionary. If you had a dictionary where the keys were, say, ints, okay, I think that's a valid key, yeah, in the dictionary, yeah, it is, then you would not use this convenience method. You'd have to use object for key and then use as to turn it back into a dictionary with int keys. Okay? Saving the database is auto-saves, so you don't actually have to save it. If you want to force it to save because you're worried that the auto-save might not happen, you're going to exit your program or something, you can use this method synchronize. It's called synchronize defaults. It'll synchronize it. That's almost it. Assertions, sorry, one last quick thing. Assertions are just a little Swift function that takes a closure as the first argument and a message as the second argument. All it does is it executes the closure. If that returns true, it does not crash your program. If it returns false, it crashes your program and prints that message out. Okay? So you could put it, some validation call or whatever. This line of code will not even execute in the version of your app that you ship on the App Store. Okay? When you build the app for release, the asserts are completely ignored. It doesn't even execute the closure. okay, let alone crash. Just ignores them. So this is debugging thing only. Okay? That's it. So Friday, we do have a Friday section. It's at the normal time, and it's going to be on source code management. Okay? Really cool way to manage your code, even if you're just one programmer working on a project by yourself. And then next week, I'm going to talk about doing custom drawing in your own view, multi-touch, like pinches and swipes and things like that. And finally, multiple MVCs so we can build a more powerful calculator. Your assignment 2 is gone out. It's already posted. It's essentially enhancing your calculator with a lot of the things that I talked about today, like tuples and defaulting values and even value types, all kinds of stuff. So you'll have a lot of fun with that.
For more, please visit us at stanford.edu.